Hello everyone, it's January 14th. Alright, it's a bit late? Yeah, early? Yeah, whatever it is. Let's just do this. I finally decided not to worry too much about the ruler, so I'm just gonna let the default ruler show. So if you see the default ruler right now, it's just gonna be look like this. It's just gonna be look like this. I think it's fine. I'm not worrying too much. That's good. One is 789, the other 120. That's good for me. But that's the only thing I did. I did not look into why Python is slow, nor did I look into what's the other thing I was looking into. How to. That is not the one, or is this the one? To check if in comment. Yeah, I was trying to make sure that it will not do the autocomplete when we are in a comment mode. So I didn't. So these two have not checked, which means that'll be something later on. All right, let's do this. Oh, problem. We're going to determine if two strings are close. Two strings are close if we can.
Oh, but not to your parents, right?
No, we're not doing.
We're not even her cousin or anything, or sure. Oh no, they might decline.
Does they even have an option for decline? Yes, they do. Yeah, put my cousin there. Yeah.
What was the name?
You can put Nicole and David.
Mm.
You can just put the
And
group.
you're on Envoy too?
Yeah, D or Dia. They will figure it out.
Should I put them all in the same group?
Yes, all in the same, because I'm gonna send them only one.
Or for familiar function?
Yes. Yeah, D or Dia, and then Nicole and David. Alright, where were we? So two strings are considered close if you can attain one from the other using the following operations. Swap any two existing characters. Transform every occurrence of one existing character into another existing character, and do the same with the other character. For example, AABB can become BBAA. All A is turned into B and all B is turned into. So every occurrence of one existing character into another existing character. So we can either swap two, or we swap basically everybody else. That's actually not a swap, it's just a change. You can use the operation as many times as possible as necessary. Given two strings, if it's possible, return true. If they're not close, if it's not possible, return false. Alright, some type of DP we need to do. Are they of the same length? They're not even of the same length. If they're close, they have to be the same, right? You can take one from the other using the following. So they have to be equal. If they're not equal, we're going to return false. Okay, that's fine. That is the first observation. If they're not the same length, it's not possible. So now they're of the same length, right? And then we have one is, we can do CA, BB, BA, and the other one is AB, BC, CC. So can we, and it's reversible from one to the other, so we can just say, okay, can we do it from the first string turn into the second string? Then we check A and C, they're not the same, so we have two options. One is to swap this C with some occurrence of A. The two is swap all the C's into A and all the A's into C. So there are the two options. Okay. Maybe, no, let's count. So No, so this case, because if we swap, right, then the total count doesn't change. Right? So C is 1, A is 2, and then B is 3. In this case, A is 1, B is 2, C is 3. Right? Therefore, if we do operation number 2, basically you can swap this. If you do operation number 1, the count doesn't change. Which means if we have a mismatch on the like A, right? This A is 2. Let's write it different way. Let's write it A, B, C. So A is 2, B is 3, and C is 1, right? So here A is 2, but this A is 1, which means if we use operation 2, we need to swap A with something that's with count only 1. And here count 1 is C, and then we check C. C count is 3. We have to do it, right? We have to do it because you cannot swap. Swap itself does not change the count, so you have to get the count right first, which means A need to swap with something as 1. So this one will become a 1, a 3, a 2. So A is done. Now we have BC, right? BC we need to swap again. They become 1, 2, 3. And once we're done, oh, that's the trick. Once you get the count right, then you can do whatever swap you want, and you can always make it right, because it doesn't matter. It does not matter. You can just keep swapping. Eventually you'll get to the right answer. Okay, therefore all we need to make sure is if we can do this, if we can swap the letters, right? We can swap the letters. And now we're saying we have the same length, right? We have the same length. Is it always possible that we can make this type of swap? Well, for one thing, they must have the same letters. If one of them has a different letter, then it's not possible. Let's say if here I have, instead of a C, I have a D, okay, with something, I have a D, then we cannot create something out of nil. We cannot say we have 0 occurrence of D, and now we can produce D. Therefore, 2 easy checks is if they are the same length and they contain the same characters, right? So we need to do these 2 checks. If these 2 checks passes, then we can check, right? Yeah, they have to have the exact same. Then are we saying we can always make it? That's not true, because if I have something, let's say we have this, B is 2, C is 2, you know, like this. Instead of this, we do a C. Okay, everybody is 2. So B we don't have to do because B is already done. So now A and C, because I can only swap this and will never swap into this case. All right, which means once we have all the matching, right? We have all the matching letters, A, B, C, all the way to Z. We have some count, right? We have count 1 on this, and then we have another set, right? We have count 2 for everyone, right? Count 2. If this value is not matched, if they're matching, done. If they're not matching, then we need to find this inside here, right? We need to find inside here, and then, which basically means we need these count to match. If the count matches, right, we don't really care who is associated with the count, as long as the count matches. Right? As long as the count matches. If it's not associated, then somebody else will be there. Then we can always replace, right? If the count is right, okay, let's say we have A, B.
2 people have the same name, I guess by last.
Try it. Do it and see once you click it what's going to happen.
Oh, maybe it depends.
On
and
the
both
group.
results will show up, and whichever you click on will be the group.
Maybe. Take a look. If I have A, B, C, D here, can I just like say randomly, no, That's DCBA. That's fine. So this A need to be 4, right? A needs to be 4, so I need to swap with something 4. Now that's too easy. Let's try a different scenario. Let's try a randomly D, A, B, C. How about this? So A is 1, but A should be 2, so we shall swap this, swap these two. Then A will be right, and B will be a different value, so I need to swap. So B, so it would be B, A, C, D, right? And then A is correct, but B is not right, so we find someone is this, so we swap. C is here, B is here. And then D is, wait, no, hold on, that's not right. So A need to be 2. Who is 2? B is 2. So now we have B2, B1, A2, C3, and D4. So A is correct, but B should be 3. So I will swap. So this one will be C, this one will be B. And the end, C and D need to swap. Right? C is here, D is here. Therefore, as long as the count is correct, then we also write. Okay. So if we do it in Python, which is what we're gonna do, let's do this. We can copy. This is gonna be today. So we do 2 counters. Okay. So we do 2 counters, and then after we do 2 counters, we are going to sort the keys and sort the values. Sort the keys and sort the values. Yes, sort the keys and sort the values. That pretty much done. That's okay. We're gonna solve this from collections and import counter. All right. We're gonna say count 1, count 2 is counter word 1, counter word 2. Okay. And then, hold a second. If len word 1 is not equal to len word 2, we now return false. Easy false. Okay. Then we do count, and then we'll return sorted c1.keys equal to sorted c2.keys and sorted c1.values equal to c2.values. Sorted c2.values. Done. Oh, my bad. It's not control, it's yank. All right, let's try this, and we are good. I wonder how I did in the past. I basically click all the solutions I have in the past. Oh my, I have a stack. Rev counter, what the hell, we have popped everything. Oh, that was, yep, that's the one. That is the one. That's true. I didn't realize the length can check, but it's slower, right? That's why you're so slow. This is faster. Keys can be compared directly. Counter value. Keys can be compared directly. It is a one-liner problem. Wow, I was struggling back then, 2 years ago. Yeah, I feel much better. Okay, so let's write a little bit update on this. We still want this, and I think the only thing we don't want is sorted. Keys can be compared directly. So, oh. Okay. No. 1657. Dick's keys can be compared directly. We only need to make sure that the two words are of the same length, contain the same set of letters, and have the same the same types of counts, not types of count, the same occurrences of counts. Technically ON, log n, because we have a sorted. Yeah, I just do ON, that's fine. 9K. Yank this, submit this, probably 120, 122. Actually, note, we could have used the values, use one line, right, to solve this problem, because the check, right, on sorted values, it already contains the check on the total length. However, it is more costly to do so compared to directly checking the two strings lengths. Done. Okay, I have no gana to do one of these tough ones. Yeah, maybe I'll deal with this one. Probably not. I know this one has like different solutions, different ways to do it, but I'll deal with some other time. To make all equal to 0. Is this the slide window, I think? Right, I think this is a sliding window. Yeah, I'll deal with this later.
Your husband's wife's name?
Kim. Probably short for Kimberly. I can just put Kim. Oh, thank you. You put that too. And just kid 1, kid 2. Child 1, kid 1, kid 2 is fun. Ah, I should know his son's name though. He mentioned a couple of times. All right, let's just continue. We've done this. Let's just do the next one. Length of the longest valid substring. You're given a string word and an array of strings forbidden. A string is called valid if none of its substrings are present in forbidden. Return the length of the longest valid substring of the string word. A string is called valid if none of its substrings are present. That's very interesting. So we're given a word CB, what, the 4 A's, right? A, B, C. So we cannot do CB. We cannot do 3A, so we can only do B, C, right? B, C is the longest. Lower English letters, 10 to the 5th, 10 forbidden words. LeetCode 4. Okay, interesting question. We can actually use, maybe we should use LeetCode for example. All right, we have LeetCode. Okay, so what we're saying is we want to find the longest substring in which none of its substrings, so none of the substring is present in the forbidden list. And here the forbidden list, can't even spell forbidden, man, is DE, LE, and E. If that's the case, so all the E's are gone, right? So everything contains E is gone. I mean, we can do I don't know, can we do a substring search? Or, sliding window. How about that? A sliding window. So we start from just L by itself. So, but L is allowed, right? Because it just says its substring is L. If L is not, L is allowed. So L, and this can be forbidden. We can turn into a set. So we check if L is in the set. If it's not in, we move on. LE, then we need to check every single one inside this is included. How do we do that? Well. If I have, let's say, if I know, given a substring, okay, give me a substring, and I say this substring is, because it gotta be, right? It start with something, right? It gotta be. So, which means we have a substring in which all the substring do not reside in forbidden. Now we want to extend it, right? We want to extend it more towards the right. So first we need to find the one in the right. Does that include, right? Does that include? So now we are saying it's everything ending, right? Everything ending. So does that include now? We say E. Oopsie doozy, E is inside, so we cannot do it, right? We cannot do so. Whatever we have in the past, that's done. So we cannot include this one, right? If we cannot include this one, that means anything ending at this doesn't work. And I already handled anything ending before. So we need to, and anything including this also doesn't work, all right? Therefore, we need to start fresh. And we start fresh, boom, that's also included, so it doesn't work. So we start fresh. Okay, we start at T. Okay, so T doesn't include, that's good. Now we move on, we say C. Does C include? C is not include. Then we need to know if anything ending at C, right? Anything ending at C, are they included in this? And nothing. You know what? This smells like a try. This smells like a try, and we should say start instead of end. I mean, we can do end. I mean, it's okay, right? We can say we make a try with the last going back to front. It doesn't matter how we produce the try, right? It doesn't matter. We do a try. So in this case, we have E, and it will be ending then we have an L, and then we have ending, then we have a D, then we have, and I haven't done try for a while. That will be interesting to do, right? So we have these, and then whenever we add a new one, right, then we need to see, starting from the new one, because it's substring, so we're going back, right? So actually LE doesn't work because we have this one. So not only E, so E doesn't work. And anything ending at E doesn't work. So if we find something that doesn't work, all right, then it cannot be included. So which means we have to start fresh. And start fresh, E doesn't work. We start fresh. T is not in it, that's good. Start from C. And then we basically check C, check everything. C is not in it. And then we go to its child, is T in it? And then we have to check every single one. And they're not in it. So we have to go every single one. Damn, isn't that gonna be... Oh, but its length is only 10. It's only 10, so we go back, at most we go 10, right? At most we go 10. So yeah, because each one, new substring, we go at most 10. So every time we go at most 10, O, D, E, right? E doesn't work. So we have the current, and then we have to go. All right, I think we have a solution for this. Let's see if we can get this right. Oopsie doozy, we have to copy again. That's not fun. It's not the most fun thing to do. And that should be Python. 1 1000, 2 1000, 3 1000, 4 1000, 5 1000, 6 1000, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 19, 20, 21, 22, 23, you gotta be kidding me. 25, 26, 26 seconds, almost half a minute to open this. All right, this is wrong on so many levels. I have to deal with this. I can't use this as IDE or even text editor if it's like this. Anyway, if set shall be a set of forbidden, because I don't want to deal with repeated. And then we need to create a try. So we do a try node. Try shall equal to, if I still remember how this is done, from collections import default dict, and then try shall equal to a lambda, right? It's a function, and then default dict, and we do and we do try inside. So it's a recursive definition. So try is a function. When you call try the function, you will return a default dict in which the default value is another try. Perfect, right? Then we have a root, basically just try, call this, and then we'll say create try for the forbidden words going from right to left. Forbidden words, for the forbidden words in which each word is considered. No, that is ridiculous. All right, that's the thing, right? Each word in which each word is traversed from right to left. All right, so we have a...
His name is Chinchi.
No, first name is Chinchi.
Yeah.
Yes, I thought you said last name.
No, I say your dad's name.
Oh man, wait, you put them in time too?
Yeah, so just so we can have in the total amount.
Wow, you're good. Yes.
Not for accepting.
Mm-hmm. Do you remember?
Chi.
That's Qilan, Qilan.
That's close.
How about this one?
Wow.
No, she doesn't.
Oh,
change.
yeah, I'll save it. money, right? You have something about money.
No, it's chill. Nice. I was going to tell you how to spell it.
I knew how to spell that too when you said it.
Ah, that's wonderful.
Hmm.
Sing menus.
I don't know. I think that's everybody.
Oh, nice. That is everybody. I'm not sure. I'll take a look later.
Although we have to formally invite you.
Yeah. I mean, that formula invite is gonna be on the envelope. All right, let's create a try. How do we create a try? Damn, I don't remember. So we're gonna go through every single word in forbidden. No, I call for set. Okay, and then we're gonna do a node which start with root, and then we're gonna for letter in word, and then need to go back to front, and if no shall equal to node letter. There we go, because it's default dict, so it will do this, blah blah blah. At the end, node, I think I used to use a star. Okay, node star will equal to, I mean, all I need to check is if star, right? So I can do true. Okay, so this is indicating the end of a word. All right, so we produce the try, then DP. No, sliding window to find the longest substring, longest valid substring. We have a rest is 0, that's good, and then we need an INJ. We can call it low and high. Okay, and actually no, because high will move forward, so I only need to low. I'm gonna say for high in range, land word. Oh shoot, cannot use word again. Damn. So what do I use? Let's use W. W here, and a letter in W. Okay. All right. So for each high, that's not right. High, because I go with index. So index and letter in enumerate word. Okay. Now what do we do? So everything, when we do it, we need to check if it is inside, and check backwards, right? We're gonna check backwards, see if it's inside, and if blah 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 at the end somebody is not, how, yes, so we're gonna check if it's inside. So we need to traverse the try. Okay, so we just say for every single letter we're gonna try. So we need a node again equal to root, right? So we need to, you know what I mean? Let me comment this. That's not what we want. So traverse the try to identify whether any substring ending at, this is bonkers. I have to fix this. Ending at letter, or I can say word high. If any is included, right? It appears in the try. If some substring appears, then we must skip forward. Right, skip forward. So we have the root, and the whole thing we need to check is for index in range from high all the way to low. I need a -1, right? And for everything we're gonna do a check. Do you want to write another function for this? In fact, I actually want to write a function for this. I think it'll make it easier. Okay, so let's say def check if exists, does exist, and then we're gonna do a root, which is actually gonna dict, and the target. You know what? That's probably not the best. Hold on, let me think again. Maybe we just do it directly. How would you do it directly? Wanna say if word I is not in, whenever it's not in, right? Whenever it's not in, then that's good, right? If it's not in the node, then we shall break. Let's say in forbidden, okay, we shall say true, okay, true, which means the first time that the first time it's not in, then we say in forbidden is gonna be in forbidden is false, okay, and I'll break. Otherwise, node will equal to word I, right? Node will equal to word I, and then we try the next one. If it's not, blah 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 blah. If it's in at the end, if node, hold on, if it's in, we go to node, right? And then if one of them, well, hold. So if we check and one of the letters already in, which means we'll have the star is equal to true, then we should just break, right? Which means if word star is equal to true, if star, okay, if star is in word, then we shall break, right? We shall break. If it's not in, not word, it's node. If it's in node, that means we have found a full word, so break. In forbidden is true, okay, then we break. If it's not in it, then we check if the current letter is in the node. If it's not in the node, then we have a substring that does not exist. Then we simply say, okay, do we simply say false? Or should we check every single one? No, we should not check every single one because it's going to be super long. So whenever the first time that we found, oh, that's fine. 7. Sin problema. All right, so we say if it's not in code, then in forbidden is false, right? Because we say ending at this. If we have something, you know what? That's not true. That is actually not true, right? Because I can have one thing is not, but maybe something else will be. Wait, hold on. That's no. If something else is, it will be caught by the try. So I think it is the first time that a letter is not in the try, then we can guarantee all the substring ending as some letter does not exist, right? Does not exist. Then we can break it out. We can break it out and then say, you know, in forbidden is false. But if anytime that the star is in, then it's true. And then word node equal to this, and then we go back up, blah, blah. If nothing is in it, if it's in, and the last one is not in. Yeah, well, something is, I think this should be sufficient, right? And it should exit early. It doesn't have to go through towards the low, because as we go through this thing, right? As we go through this thing, at a certain point, we will exhaust all the word, because the word length at most is 10. So we go to a certain position and boom, it's not there. Okay, so when this go out, we'll check if in forbidden, right? If in forbidden, if it's in forbidden, right? If ooh, I have another thing I need to do. So res and current, right? Have this. Then we say if in forbidden, right? If we're inside forbidden, then whatever it is, we need to skip. So low shall equal to high plus 1, and then move on to the next one. Because the current high, it just doesn't count, because include the high will be inside. Else, if it's not, then will be current plus equal 1, whatever current plus equal 1, and the rest equal to maximum rest and current. And this, I need to reset current to 0. So now we do that, we go through the whole thing, and then we're gonna return rest. All right, moment of truth. Let's take a look. Yank it. All right, is this right? Oopsie doozy. I think I forgot to reset the forbidden. And I did reset the forbidden for every single thing. Oh, basically I didn't make any change. Damn. Okay. So yeah, something is wrong. How do I check? All right, it's fine. It happens all the time. Let's do this. So we have CBAA 1 2 3 4 BC, right? Forbidden AA and CB. It's all right. That's all right. Now I think the idea is correct. Just the implementation probably is not right. Forbidden. Longest. This is gonna be word forbidden. Okay, and that's so this is gonna be LeetCode 2781. Oh, I forgot the answer. Answer is 4. Okay. Now we need to do some print debugging. Let's print this. Let's print root. Just kind of see if this one's right. Root. Oh my goodness, that's definitely not the most friendly. Let me move this up. Actually, I don't need to move up, right? Yeah, I don't need to move up. So we have B, we have BC, BC star, and A star. Yeah, I think the try is right. I don't think anything. The try is wrong. What happens is here. So I start with node equal to root. Every time I go node equal to root, that's good. Forbidden is true. In forbidden is true. And we're gonna go from high. So at the beginning, this is 0. This is -1. So we go 0, which is C. And then if this is a node, no, this is not a node. Is this in? This is not in. So node will equal to would. Oh, that's the problem. All right, it's a typo. It's a typo. Okay, let's go down. Dude, not result is 1. Okay, so still wrong. Okay, let's comment this out. Okay, node equal to, but what I is not in node, I shall break it already. So it's not current plus equal 1. Good. So that's the C, right? Next, I go to B. And when I go to B, which is the second one, right? And the low doesn't change, right? When I go to B, then actually I don't need current. I just realized I don't need current because I already did the high and the low. I'll deal with this later. So we go to B, root is not, but would I not in node? Oh, it's in node, right? It's in node. B is in because I have B is in, okay? And then we keep going to the node for C, and then this is, and I is also in node. Then we go to the root, and then boom, input forbidden is true. Go down here, low equal to high plus 1, current equal to 0. So basically the pointing, low pointing to here, and I only have C. I only have C. Okay, that's actually not right because you have C and you have B. I didn't count B, right? I did not count B. Now you have A, which is in it, but then B is not. You know what? I think at this point I need to print out this whole thing. I need to print out. What is my letter? Okay, low, high, letter, current. Actually, probably I don't need current. Let me just print out this. Just take a look. All right. So 0 C, low is, because I upgraded. Low become 2, high is 1, and it's B. That's right. Low is, yeah, because I always move it forward. Because A is always in it. No, it shouldn't be like this A. I should, like A, BA should be in it, right? Yeah, BA should be in it. BA should be in it. But when B is wrong, I immediately put the low up. That does not sound right. All right, that does not sound right. What should I do? I should not ignore the whole thing. So basically, whenever this is true, we went from the current counting backwards, and on one of the letter, it becomes a forbidden. So ideally, I shall move just forward by 1, right? I shall move just forward by 1. Whatever that letter is, I shall just move forward by 1. But how do I know I should just move forward by 1? Exactly. How do I know I should just move forward by 1? I mean, I do know, right? Because I have an I. I have an I here. Right? I have an I here. Which means at certain I, right? At certain I, it's in something is in node, and I'm going down, back up again, and then it's become forbidden. You know what? Let me I feel like I'd like to make some changes. First of all, let me paste this one here. So we check, we go forward, and then we do this. right? Then we'll break. Now when I would break, we still have the I value because it's still in scope, right? It's still in scope. And then we shall say if it's forbidden low does not equal to this, low equal to I plus 1, because from I to high, that is inside. So we'll do I plus 1. Okay, so we just do I plus 1. And this set to 0. So if we do this, and we don't need current, okay, we don't need current, because all we need to do is, we don't need this, we don't need this, we just need from high minus low plus 1. That should be sufficient. All right, let's take a look. Oop, this is right. Let me comment out this and page up 17K yank it. Okay, let's run both. Is this correct? All right, that looks promising. Let's delete these print statement, and I want to add one more, right? One more. So substring I, substring would I towards j, no, I towards high, right? This is forbidden. Thus we move low forward by 1. Yeah, I think it should be fine. All right, let's try it. Ugh. All right, that's not right. This is not correct. Oh my god. Let's debug a little bit. ACB and ACB, the whole thing doesn't work, right? Anyway, I start from the first A. Anything A is in it, that's fine. That's fine. It's we don't do this. So which means what I is in node is A is in. So we move on to the next, which basically is A again. And this is in node no. Coming back up. Oh, in forbidden become true. In forbidden, okay, I think in forbidden shall become false. So by default, right? By default, only if we hit this, which means we can delete this, right? So only time that is true is when this hits, right? That's true. Otherwise, whenever this doesn't hit, okay, so if we do this, let's try. Is this right? All right, try it again. Yes. Yes. All right, it's not the fastest, but yeah, we got it. We got it. Pretty much, yeah, pretty sure there's a better idea, I think. But maybe implementation-wise, I don't know. It's only 30%, right? It's pretty bad. That is pretty bad. Okay, so we create a try based on the forbidden words. And for each word, the try is created from right to left. For each letter in word, right, in word, we examine whether any substring ending at the letter exists in the try, right? If none of the words in try fit any substring ending at the current word, current letter, the current letter can be extended, right? Can be extended, can be added to the current substring, right, to the current substring, and we extend. I'm trying again. And it can be added to the current valid substring, right? Otherwise, we need to shrink. We create it. Then we use sliding window, right? And we need to shift the start of the valid substring forward. The new starting position should be one more to the right of the latest, right, of the shortest matched forbidden word. That makes sense? One more to the right of the start of the shortest of the forbidden word. Now the try is going to take, so we're going to say OM plus 10 times n, where m is the total number of letters in forbidden, right? This is the cost of building the try. Then 10n is the cost of traversing through the word and for each word, and the traverse of the try for each word. Does that make sense? Yes. Okay, I'm gonna copy this. Let me just run this one more time so I can save this. Huh, look, it becomes faster. Ugh, that's wrong. Hold on, let me do one more time. So we do this and then we do this, yes. Wait, that's not right. I didn't copy. Shoot. Oh. Hold on. Yeah. Because this already copied. Damn, still very, very green in this Vim stuff. There we go. Page up. Okay. I think this one deserves more attention. I'm pretty sure there's a better way to do this. Yeah, I think there's a better way. Or not just a better way, maybe we can have some trick here. Like maybe the low is not equal to this. Maybe I can move forward more. I don't really think we can move forward more though. We're doing this and we are hitting the first one. I doubt it. All right, we'll take a look again. We'll leave it here, and tomorrow we will go through this. Maybe it's a non-try solution. Hash map and try. Interesting. Hash map and try. Sliding window. Try and this is basically a sliding window. Anyway, that will be it. All right, I will end it right here and see you guys tomorrow. Adios.